Assalamualaikum warahmatullahi wabarakatuh. My name is Herunedi Dwi Agustian, NPM G1D 020063. Okay, I will describe the magazine about ultralight batteries for electric airplanes. Electric aircraft are the rank with prototypes in development in every size from delivery drones to passenger aircraft, but the technology has yet to take off, and for on reason lack of the suitable battery for alert passenger aircraft to take off course and land range of kilometer away will take batteries that weigh tons of kilogram far too heavy for the planes to able to get into the air in the first place. Even for relatively smart aircraft such as to set range, the sheer weight of batteries limit the plane's payload, curtails its range, and cause constraint where the aircraft can fly. Reducing battery weight will be an advantage not only for aviation but for other electric vehicles such as cars, trucks, buses, and boats. All of low performance is also directed to the energy to weight ratio of their batteries. For such application, today battery of choice in lithium-ion it reached maturity years ago, with its new instrumental improvements smaller than the last. We need a new systems. Since my company, Oxys Energy, in Oxfordshire, England, has been working on one of the leading continents lithium sulfur. Our battery technology is extremely lightweight. Our most recent model are saving more than twice the energy density typical of lithium on battery. Lithium sulfur is also capable of providing the required level of power and durability needed for efficient, and most important, it is safe enough. After all, a plane can handle a student fire or some other military by simply pulling to the side of the road. The new technology has been a long time coming, but what is now over the phase of light trail have already been complete. The positive electrode, known as the cathode, absorb electrons during these changes. It is connected to an aluminum foil collector coated with a mixture of carbon and sulfur. Sulfur is the active material that takes part in the electronical reaction but is in electroinsular, so carbon and conductor deliver electrons to where they are needed. 3 is also a small amount of binder added to ensure the carbon and sulfur hold together in cathode. The negative electrode or anode release an electron during is hard. It is contract to for lithium foil, the lithium to its current collector, but it's also an activated material taking part in the electrochemical reaction. An electrolyte facilitated the electrochemical reaction by allowing the movement of ions between the two electrodes. A reaction reverses the sequence and plant current forces electrons to flow in the opposite direction, causing the sulfur electrode or cathode to give off electron curving LES to lead. The process continues to add for sulfur atom step by step until is corrected in the cathode and each time electron are give up. Lithium ions are produced that then diffuse toward the electrode, combining white electron at the lithium electrode from electron metal with all the LIs has been converted to LIs. The cell is fully charged. Anatomy of battery. The description is simple in reality. The reactions are more complex and numerous, taking place also in the electrode and at anode. In fact, over many kinds and these kinds. Chastely, it is the side reaction that shows reaction in the lithium sulfur cell. Many saying the selection of the offered material on the configuration is the fundamental underlying challenge that must be to produce efficient cell with a long lifetime. One great challenge for both lithium ion and lithium sulfur technologies has been the tendency for rapid charging and discharging gameplay to degrade the anode. In the case of lithium ions arriving at the electron normally fit themselves into interstates in the metal, a process called intercollection. But sometimes ion plate the sulfur, forming an nodes on with outer plating can achievement for many cells of flatman or direction might grow until at reason the opposing electro and sorting circuit the cell, sourcing a source of energy in the form of heat that evaporates makes the cell. If one cell breaks down like this, in that trigger a neighboring cell to do the same, binding a domino effect known as thermal runaway reaction in common parallel of fire. Developing solution to the drag problem is crucial to producing a cell that can perform at high level over many distinct cells are promising strength. We have been pursuing at axis in voltage coating the lithium metal anode with him later of ceramic material to prevent direction. So the ceramic material need to have high ionic conductivity and by electrical insulating as well as mechanically and symmetrically robust. The ceramic layers allow lithium ion to pass through untreated and be incorporated to the bowl lithium metal beads. We are doing this work on the vortex layer for the anode in partnership with Volution and Leitat, and we're optimistic that I will dramatically. If the packing is done right, the energy distance of battery can be halved to 18% of the cell right at 450 can be packed at more than 360 in the vinyl battery. We expect to do better by integrating the battery into the aircraft. For instance, by making the wing space do double as the battery housing, we expect that doing to will get the figure up to 18%. Increase the number of times is a child that can be discarded and cared, and it's not our only partnership. We are also working with Arkema to improve the cathode in order to increase the power and energy deficit of the battery. In that, the key effect of lithium-ion battery over their precedent and of lithium sulfur over lithium-ion is the great amount of energy the cell can pack into a small amount of mass. The lead star battery that cranks the internal combustion engine in car and store about 15 watt-hours per kilogram. Typical lithium-ion disket can hold from 1002 to 68 65 Wh per kilogram, depending on the other performance target of which is banned. Optimized so is a pack for a long life. Oxys developed a prototype lithium sulfur for cell the for samples of of 470 kilogram and expert to rates 500 kilogram a year. And because the technology is still new and as room for improvements is not to achieve 600 kilogram by 2025. Like lithium ion cell, lithium sulfur cell very silky from one. Other this definition as well as difference in the cell position in the battery pack may cause some cell to transition around hotter than other over time. So as high temperature slowly dragged performance, so it is important to minimize the power difference from cell to cell. This is usually achieved using a simple balancing solution in which several resistors are connected in parallel with a cell, are controlled by software in the BMS. Even when charging and discharging, rates are kept with safe limits and battery of style energy extract heat. So typically a hidden thermal management system is necessary. An electrical car can use liquid cooling, but in efficient air cooling is more preferred because it adds less weight. Of course, the battery can be placed at point where air is naturally moving across the surface of the airplanes. The wing. As not above, a battery pack typically arranged with the cell both in parallel and in series. However, three or more to arrangement of cell. Of course, the battery is a mission correction supplement a plan. So, you want returns for action safety. You call, for instance, dividing the battery into equal parts so that if one half fits can be discounted, leaving the aircraft with at least enough energy remaining to throw this in landing. All these design should involve threads of which are different for different plans. For who with manages the threads of order or battery design of three different aircraft. 1. High altitude pseudo styling. 2. Electrical vertical takeoff and landing aircraft. 3. Like fixed wing aircraft. 3 factors will determine whether lithium sulfur batteries ultimately scores or fail. Freeze is the successful liquefaction of the batteries into multiple aircraft types. To prove the principle, second is the continuous refinement of the cell chemistry. Third is the continued reduction in the unit cost. A plus here is that sulfur is about as scarce as material get so 3 reason to hope that with volume manufacturing the unit cost will fall below that of the lithium ion decision of will be reckoned for commercial success. This state-of-the-art plant should be commissioned and operating by 2033 if the economy of cell proof of an if the demand for electrical aircraft rises as we expect. The lithium sulfur battery could be to supply lithium ion better. Let is fail and what work in the earth to what we are with. That's all I can say. Thanks for watching my video. Wassalamualaikum warahmatullahi wabarakatuh.